Okay, I think we're, videoing here. All right, so now 29 on or 76 on, but I changed it to 29 through 40 so I could grade you, but you know that in my class. All right, so this one's a little bit tough because I know concave not down means, and especially in that yellow graph for D, means decreasing at concave down a decreasing rate. But what it means, though, for the volume of the pool, if the rate of the water leaking from the pool is increasing, if it's increasing, then the volume is decreasing at a faster rate. And that's what this means. Like this, so think of it as slope of tangent lines. They're getting more negative, but that means the rate at the way the water is decreasing is actually increasing. So it's leaking out faster. The volume is getting smaller faster. All right. So if that's what this really represents here. And then it tapers off. It's still decreasing. I know that's at an increasing rate, but that's because the slopes are negative. As far as the volume of the pool, though, the volume is going slower at a decreasing rate. So it's emptying slower. So that's what these graphs look like there, and that's the best way I can explain why D is the right answer there. All right, next one, binomial theorem. I know in our class we kind of skipped this, not kind of, we did. So anyone that was in Math 2 honors last year remembers the binomial theorem. This is Pascal's triangle right here, just a simple 1, 1, 1, 1, 2, 1. Hopefully you can see the pattern. 2 plus 1 is 3. That's how the next row is built. What humans, I'm giving you a real quick Pascal's triangle demonstration, figured out is this pattern. When they take binomials to certain powers, these coefficients result, and they are actually Pascal triangle numbers. They literally took x plus y times x plus y times x plus y times x plus y, multiplied it out, added like terms, and got this answer. Pattern developed. They knew Pascal's triangle could be applied to the coefficients of any binomial raised to any power, basically. And then the formula results in I need a Pascal triangle number. And then for the x to the third term, that's this term right here. So that's 4 from Pascal's triangle. Now, what we taught the Math 2 honors people as well, you can get Pascal triangles directly from combinations. That's what that 4C1 is. This is 4C0, which is 1, 4C1, 4C2, 4C3, 4C4. So again, this is speaking directly to those who have heard of what a combination is. Down here, to the eighth power, this is 8C1, 8C0, sorry, 8C1, 8C2, 8C3, 8C4, 8C5, 8C6, 8C7, 8C8. Went way too far into this the way I wanted to. All right, and then the Y is actually -5 in this scenario. So you place these parts in here. So this happens to be X, so X is X, but Y is actually -5. So that's what this represents in this part of the polynomial. So this part of the polynomial has a coefficient of -5 times 4. So -5 to the first times 4 is the right answer. Tough if you've never seen this before. All right, many regressions here. This is a flat out regression. So just you can pause this. I'm going to go real fast. L1, L2, that's stat edit. Then you calculate a quadratic because it says it's quadratic in here. Quadratic regression. And then when you do the regression, which is stat calculate, then when this comes up, you want to put y1 in this position. That's either by, oh, my calculator is going to take forever to open here, but that's either by alpha and then the fourth button up at the top. I'm waiting for my calculator to open to show you this. This is what I deal with every day. Okay, there it is. So it's alpha either, so let me hit second quit. So it's alpha trace, and then that's where that comes from, or it's vars, y vars function, and then you put y1 in that position. So I did want to show that, and you want to store that there, otherwise you can't calculate the next thing. So then you hit calculate, this comes up, and then since you stored it here, it'll show up in the y1 screen. Then ultimately you do this. on the main screen, you do, this is like f of notation. Since y1 has this equation, the regression equation, y of 8 will give you the output value, input, output. Okay, feel free to look at that again if you want. All right, this one you have to do a graphing calculator, wild. So g of x, or f of x equals sine square x squared, weird. And then g of x is that function plus 0.5. What is the lowest value for x where g of x equals 0? Okay, so that's what you do. New equation, and then y2, make that equal to 0. We're going to do an intersection then of these two. Make sure your calculator's in radians, and then I hit zoom trig, and this worked out real nice. So then you hit second trace. Now that I have this open here, I don't have any equations, but second trace intersect. Okay. And then move close to this position because this is the first one. So what is the lowest value of x where g of x, this is for x is greater than 0. Thank gosh they said that, because all of these are zeros and all these are negative, which are lower than a positive. So good thing they have that condition there. So it's the first positive 0. And then you find the intersection. Remember, you have to hit enter 3 times once you get close. Arrow over close, hit enter, enter, enter until it says this, and then that's the answer. Next, given table function transforms. I didn't remember this question. Vertical dilation by a factor of 2, and then remember, horizontal dilations by a factor of 3 are inversely related. So that is a horizontal dilation by a factor of 3. This is how it works. Now when it says find g of 3, you can plug it directly into this. 3 over 3 is 1. F of 1 is 4. So then 4 times 2 is what results in the total completion of this question. 2 times 4 is 8. Okay, tough. Remembering horizontal dilations are inversely related. Next, consider function f of g, f of x and g of x. When do they intersect on the interval from 0 to pi? Now, there might be 2 intersections from 0 to pi. I believe there is, but I believe only one is listed. So I didn't check this other one. I probably should have, but usually it's just one answer applies. So, a little nervous about that. I'm not going to go ahead and type that back in. But definitely, I typed in 2 cosine. The 2's invisible there because of the blinker when I pulled the screenshot. Y1, Y2, and then again, zoom trig and make sure you're in radians. Boom. Well, from 0 to pi, I just got to make sure that this x value is smaller than 3.14. And then yet again, I found an intersection. So this is how you find out where they're equal, all right? And that's what this says. Where they intersect is where the 2 equations are equal. So, and obviously you can see the intersection point there. Thank you again, Valente. Here, I keep putting that on each page so you know I'm not stealing your product. All right, I actually figured this out without doing math. Second term of a geometric is 16, fourth term is a 4. So I knew second term was 16, then there's a third term, then there's a fourth term. I figured out it was half. Half of 16 is 8, so this would be 8 here, and then half of 8 is 4. Then I look up here, and there's only a half here, and then going backwards, doubling. So this would be 32, and then this would be 64. So I was expecting 64 as our initial term, because our initial term is always a sub 0, but then I see some positives and negatives. Then I'm thinking, oh, this could oscillate between positive and negative. So it could also be negative half. So this could be negative 8, and then negative half of negative 8 is positive 4. All right, so that's why I was able to figure out 64 could be the leading with negative half as the R value. Or this is the geometric format. It's sum A times sum R raised to some power. So if I have the 8 of the fourth and the 8 of the second term, that is 2 iterations of R's away from each other. So that's why 4 minus 2 is the exponent, right? So it takes me 2 R's to get from A sub 2 to A sub 4. A sub 4 is 4, A sub 2 is 16, divide, square root of 1/4 is actually a half. Oh, but it's plus minus. So actually this is the right answer. All right, other ways I can explain it, but that's good enough. All right, and then this whole idea of looking at the rectangular coordinate plane, how does this translate to a polar coordinate plane? as far as what the points are doing compared to the pole, which is the origin. And what y equals 0 here is, that represents the pole. So then as we're moving from left to right, this is as inputs increase, the outputs for the polar graph are getting closer and closer and closer to the pole. So they're coming towards it. And now they're going away from the pole. And then they're getting closer to the pole in this interval. And then they're moving away from the pole. Okay, so that's why those are the intervals. From B to C, you're moving away from the pole, and from D to E, you're moving away from the pole. If you read that question, that's what it's saying. Next one, what do we have? Some logarithms. So the first thing I had to do is solve for this B. B is an unknown constant. If f of negative 2 equals 6, then find, well, okay, that gets the ball rolling. Input, negative 2 for x. I didn't highlight that. I should have. So I have that highlighted there, but not there. Yoink. Negative 2 for x, and then 6 for f of x or y. And then I solve through a logarithm. My class knows. Log base 2 of 6. That's a 6, not a b. Unfortunate number choice when my b's look like 6s. Equals the exponent negative 2b, or not to be. Divide by negative 2, and you get this decimal. It's right here, negative 1.29. Now, you don't want to round. That's why I kept my calculator as it is. So now what's f of negative 1? You plug this in for b. That's bx, and then I'm plugging in negative 1 for x. So I kept that answer intact and then raised 2 to the answer times negative 1 power, which just makes that positive. And then that's my output value. All right. Next one, weird question. Here's this graph, negative 6. That means the amplitude 6, and they name that letter A. T, they say, is the function's period. Well, the period of this function is 2 pi, over a half. 2 pi over a half is 4 pi, which is approximately 12.57. And then M, they're calling the midline. Well, the midline's y equals 3, because I have a amplitude of 6, that's 6 up to 9, 6 down to negative 3. So y equals 3 is the midline. Well, 3 is less than 6, which is less than 12.7. So that's the correct alignment of these mysterious letters. All right, weird. Guess just reading math is what we're testing. Thank you. All right, anyway, keep saying that each question. Yet another regression. All right, so go in stat edit, L1, L2. Not showing you that again. Next thing, it says it's a linear regression. Great. Do a linreg. Don't forget to store the equation in y1. All right, but then it says predict the total number of customers inside the mall will reach at what value. So that means you want to get your regression equation. That's by doing all this, storing it in y1, store or put y2 equals 1,000, then make sure your window fits your data. So my y max for sure should be greater than 1,000 just to see the horizontal line. And I surmise this would at least happen is this in days or clock? It happened within 15 hours at least. And then if it didn't, I just extend it. But there we see the intersection of these two. Remember, second, trace, same thing. Second, trace, intersect, hit enter 3 times. You'll get that intersection. Then the last one could have been a regression, but then I remembered if it's cubic, then there should be third order differences. So I found the first order differences, the second order differences, and then the third order differences. Now, sometimes when you have real world data, it's not perfect that this happens, but they're close. That's when we have the regressions and the residuals, the errors in the model. But this one's perfect. So then what I do, the green represents my reverting backwards now. Okay, so the third order differences, should be 4 away. That means this value has to be 19, 4 above 15. This has So then now what I can do is now take this 16 plus 19, because 1 plus 15 is 16. So these order differences have a pattern, but it doesn't matter. I found the next difference from here to here should be 19. So 16 plus 19 is 35. And then this should be 35 away, keeping this pattern intact all the way through this order difference pattern. So negative 30 plus 35 is 5. So we did that actually before we even did regressions. When models were perfectly quartic, perfectly cubic, perfectly quadratic, we could find future data values by doing this pattern. So that's why D is the answer. All right, that wasn't as bad. I will probably tomorrow do the um, written portions as well, FRQ 1, 2, 3, and 4. Thanks for watching. I hope I know how to stop this.